Hi students, am I live? Am I audible? Let me know in the chat box. Perfect. I think I'm live. Let me check. Let me check. Yes. ठीक है. Let me know in the chat box if you can hear me clearly because we are using a different setup today. ठीक है. The class has started. The class has started. Hi, Bacha. Hi, Supriya. Welcome back to my class. Hi, Sivasakti. Hi. Audible? Audible? Perfect. Hi, Tanishka. Hi, welcome back to my class. Welcome back. So today I will be looking over here for to look at the chat box. Okay, we are using a different setup today. Chalo, live and audible. Perfect, perfect. So let us begin the class. Today we are taking on the second chapter from your 12th class, which is your alcohols, phenols, and ether. Right, if you're preparing for your JEE second attempt or even your advanced and you want to prepare, so right now is the best time, and today I'm going to revise this chapter with you guys. What are you going to do? All of the reagents that are present in the chapter, all of the name reactions that are present in the chapter, and what variations can be there. This stereochemistry we're going to learn about in this session, and what else we're going to learn? We're going to solve so many different kind of questions so that you get a hint of what you should expect and how you should approach the question in your exam. So very important session once again, because lots of questions are asked from this chapter, whether it is from the name reactions, whether it is from something else. So it is a very, very important chapter. Let us begin. Let us begin. With the duration of this class, you can expect this session to extend up to 3 hours, not more than 2.5 to 3 hours. We're going to complete this session. Okay? Voice, I think, bacha, it's very okay, voice, because all other students are saying it is okay. So you must increase the volume on your whatever laptop or mobile you're seeing this lecture on. Okay, let us begin. Chalo, let me get a remote control. It is here. Does it work? Does this work? No, this doesn't work. Okay, so we will use the same old keyboard. Okay, first of all, what are alcohols? So we will take an alkane, and in an alkane, what am I doing? I'm replacing one of the hydrogens of the alkane with the OH group. Okay, this kind of substance, this kind of molecule is called an alcohol. Very easy. Again, what are the classifications of alcohol? It can be, again, the alcohol, the OH group can be added to a sp3 hybridized carbon or to a sp2 hybridized carbon, right? So these are the variations, the classifications of alcohol. For example, the very famous example of sp3 hybridized alcohol are the benzylic alcohol, which looks like this, CH2OH, right? These are the benzylic alcohols. Remember, benzylic alcohols. Similarly, what are sp2 alcohols? Whenever aryl alcohols are there, like phenol. Like phenol is an example of sp2 alcohols, right? So some of these classifications which are given in your NCERT, for example, they have also classified alcohols into diols, triols, or monohydric alcohols, right? Monohydric means in the entire molecule there will be just one OH group. For example, in CH3, CH2, CH2OH, it is a type of monohydric alcohol. Similarly, if I write an alcohol somewhat like this, CH3, CH, and here also CH2OH, and here also one OH group is present. These kind of alcohols are called, number one, dihydric alcohols, and number two, because two alcohol groups are situated right next to each other, right? One carbon contains one OH group, the other carbon right next to it again contain OH group. Such groups are called, such alcohols are called vicinal diols. What are they called? Vicinal diols. Similarly, if, for example, in a molecule like this, CH3, COH, OH, and here it is CH3 once again. So can you see this is again a type of diol, two alcohols, two OH groups are present on the same molecule, but they are present on the same carbon this time. Hence, bacha, these are what? These are called gem diols. What are they called? They are called gem diols. Is this thing clear to everybody? So these are some of the classifications which you should know. What are benzylic alcohols? What are aryl or phenols? They have too much differences, right? And what are vicinal diols? What are geminal diols? You should all know that. Okay? Should I move forward? Good afternoon, Umair. Good afternoon. Beta, what voice issue is there? Chalo, okay. Next, let's move on to the next slide. Now, next thing, because in this chapter, we're going to read about three kinds of molecules. The three kinds are alcohols, phenols, and ethers. Let us look at this structure one by one. This is how an alcohol, simple alkyl alcohol looks like. For example, methanol. Methanol has a structure like this. This is the methyl group over here, and to this carbon, one OH is attached. Right? Now, look at the structure and the bonding in this molecule. What can you see? Can you see that this oxygen actually has two lone pairs of electrons? What does it look like? For example, this is the oxygen group. Then two lone pair of electrons are present on the oxygen. One is bonded with the hydrogen. The other bonded is with the carbon molecule over here. Can everybody see that? Right? Now, let's talk about what is the hybridization of this oxygen over here. The hybridization of oxygen is sp3. Okay, remember, the hybridization of oxygen is also sp3, and the carbon's hybridization is also, this is CH3, right? It is also sp3 hybridized carbon, right? Now, when the hybridization of alcohol is sp3, we know what is the structure, what is the geometry of a sp3 hybridized structure. It is a tetrahedral geometry, isn't it? Tetrahedral geometry is shown by this oxygen atom. Remember this thing. If tetrahedral geometry is shown, what does it mean? It means that the angle, this angle should be how much? What did you study in your organic? How do you start your organic? By reading about the tetrahedral angle, which is 109 degrees, 28 minutes. But can you see the angle given over here is a little bit less, which is 108 degree and 9 minutes and not 109 degrees. Why is it become a little less than the actual tetrahedral angle? Because, bacha, due to the repulsion of the lone pairs on the oxygen. Oxygen has two lone pairs on it. So, due to lone pair, bond pair repulsion, the angle becomes a little bit less. Okay? That is why this angle is a little bit less than the actual tetrahedral angle. Understood? Next is we're looking at the structure of phenol. Phenol, again, what is happening? Oxygen here again is one more time sp3 hybridized only, right? Can you look at the two of the lone pairs on oxygen, one lone pair and second lone pair, right? And here, can you see that the angle is exactly 109 degrees? What you expect it to be the tetrahedral angle once again, because oxygen is again sp3 hybridized, the bond angle is 109 degrees. But what is one difference you're observing in phenol than the methanol? One difference is that the CO bond length, can you see that the CO bond length over here is 142 picometer, while the CO, the carbon of phenol, and this bond length is only 136 picometer. Why is that the case? Because, bacha, in phenol, what happens? I'm again drawing the structure of phenol. Looks like something like this, right? And here's the oxygen atom, right? So here the lone pair on the oxygen atom can actually undergo resonance with the benzene ring, isn't it? So when it undergoes resonance with the benzene ring, can you see that this bond actually acquires a partial double bond character? Hence, the OC bond in phenols is reduced due to gaining a partial double bond character. Okay? A resonance structure, if I draw of this benzene, then here a partial double bond character is observed. Hence, this bond length actually is a little bit lesser in number. Okay? Similarly, these two are clear to everybody. the difference between methanol and phenol. Next is ethers. In ethers, what you should expect? Ethers look like this. There is a carbon molecule, then there is an oxygen molecule, then again a carbon. So this kind of structure is actually called the ether molecule. So again, the oxygen is again have two bonds, right? So this oxygen again has bacha two lone pair of electrons. Once again, what is the hybridization of oxygen over here? Again, the oxygen is sp3 hybridized. Can everybody see that? Okay, again oxygen is sp3. Hence, what should be the bond angle? The structure should be tetrahedral. The bond angle should be 109 degree and 28 minutes. But what is the bond angle? It is actually a little bit more than 109 degree 28 minutes. Why is it more? Once again, look at the structure. Can you see that here two big methyl groups are present? Can everybody see that? The oxygen is in the center and to the sides two big alkyl groups are present. So between those alkyl groups, there will be a lot of repulsion, right? So due to that repulsion of the alkyl groups, the bond angle actually increases. So this is how much you should know about the bonding and bond angles as well as the bond lengths of the alcohols, phenols and ethers respectively, and the reasoning behind it. Is this thing clear to everybody? Is this thing clear to everybody? Okay? Okay, Supriya is asking, ma'am, what is the condition for sp2 hybridized alcohol? So I'm going to answer that right now. But look at the carbon. To which carbon the alcohol groups is attached, that will actually tell us what is the hybridization of alcohol. For example, this is the carbon, right? The normal alkyl carbon. For example, to this carbon, there is one H group, dusra H group, the third H group here, and the fourth is the OH group over here. Now, what is the hybridization of this carbon? Because this carbon is forming four bonds, okay? Four bonds of carbon contributes to the sp3 structure. Remember this. sp3 means four bonds with carbon, which means that it is four bonds. So better than saying four bonds, I would actually say what, bacha, for the sp3 structure is four atoms attached to carbon. Okay? Four atoms attached to carbon will mean that it is a sp3 hybridized alcohol. Similarly, look at phenol. What is the structure of phenol? This is a phenol structure, right? This is a phenol structure, and here alternatively double bonds are there, and here the OH is present. Okay? Now look at the carbon to which the OH, the alcohol molecule, is attached. What is the hybridization of this carbon? This is a sp2 hybridized carbon. Why am I saying that this is a sp2 hybridized carbon? This is very basic chemistry, bacha. Here, look at this carbon. Okay? How many atoms is this carbon attached to? This carbon is attached to one atom, second atom, and third atom. Can you see? So in sp2 hybridized, what can we say? What can we say about the sp2 hybridized things, bacha? That the sp2 hybridized carbons and sp2 hybridized alcohols are actually those which are attached to three atoms. Okay? The carbon is attached to three atoms. In sp3, four atoms are attached to the carbon. Is this thing clear to everybody? Is this thing clear? Chalo. Next, we will move on to the next thing, which is the physical properties of alcohol, right? So what are the physical nature, like what is its boiling point, what should be the melting point, right? So bacha, what is the nature? Alcohols are colorless liquids with a specific smell. They actually have a smell. How do you remember that? Because remember that ethanol, the alcohol that people drink, right? People consume ethanol. It has some kind of bad smell, right? So in that fashion, you can actually remember the alcohol are colorless and they actually have some specific smell. Okay? And they are soluble in water. Why are they soluble? because this is the structure of ROH, and here again this alcohol can actually form H bonds, H bond with another alcohol or even the water molecule. For example, like this H2O, right? So alcohol can form H bonding with water molecules, hence it is soluble in water. Okay, and these are partially soluble in organic solvents. Okay, next is these are liquid in nature up to 12 carbon. More important fact. Next, what should be the boiling point depend upon? So, bacha, boiling point depends upon the molecular mass. More the molecular mass, more will be the boiling point. It is directly proportional to the molecular mass, and also it is inversely proportional to the number of branches, which means as the branching will increase, as the isomeric branches will increase, the boiling point is going to decrease. Okay? The same funda we are applying in every boiling point, whatever we are reading in the organic chemistry, right? And also the next thing that you should know, boiling point of alcohols are higher than the equivalent ethers. Remember that. If you have to compare between ether and alcohols, alcohols have a higher boiling point because ethers are lesser polar structures. Okay? It is due to intermolecular H bonding, which is only and only present in alcohols. Ethers, even though you should argue, ma'am, ethers also have a oxygen present over here, so they should also form H bonding, but they do not show H bonding. But only alcohols show H bonding. Why do they not show? Because this is a lesser polar molecule. These are not that polar in nature. Ethers are not polar in nature. Okay? Next, is this thing clear to everybody? Beta, after 12, it will be solid. It will be solid. Sukya is asking them after 12, what will be the nature of the alcohol? It will be solid in nature. Correct? Correct? Chalo, next. Difference between degree and hybridization of alcohol, Anurag is asking. So, okay, let me also, all the live students that are watching, let me answer their question. Anurag is asking them, what is the difference between degree of alcohol and hybridization of alcohol? Correct? So, bacha, degree means what? Degree means, for example, if I write alcohol like this, CH3, CH2OH. Okay? Here, the OH is attached to the carbon, which is attached to just one more carbon, right? This carbon is attached to just one more carbon, hence this alcohol is a primary alcohol. Similarly, look at this example, CH3, CH2, here again I will write CH2 or CH3, and here I will write CHOH like this. Now can you see to the carbon where OH is attached to this carbon, two other carbons are attached. Can everybody see that? To the carbon to which OH is attached, another two carbons are attached to it. Hence, this is a secondary alcohol. Similarly, there can be another tertiary alcohol like CH3. To this carbon, I am attaching 3 methyl groups. And here the OH is present. So, again, the OH is attached to that carbon to which 3 other methyl groups or alkyl groups are attached. Hence, this is a tertiary alcohol. But let us look at their hybridization now. In all of these things, the carbon is attached to 4 atoms. You can just count the atoms in all of the cases, right? The carbon to which alcohol is attached with 4 other atoms. Hence, the hybridization in all of these cases is sp3, even though their degrees changes. Hybridization depends upon how many atoms the carbon is attached to. If the carbon is attached to 4 atoms, it will be sp3 hybridized. If the carbon is attached to 3 atoms, it will be sp2 hybridized. If the carbon is attached to just 2 atoms, it will be sp hybridized. But degrees depend on this. Degree is this, hybridization is a different thing, degree is a different thing. Understood, Anurag? Okay, let us move forward. But Supriya, the H bonding also depends upon the polarity of the molecule, right? For example, Supriya is again asking, ma'am, why ethers do not show H bonding? I'm again drawing the structure of CH3OH structure. This is methanol alcohol structure. This can form, this H can form a hydrogen bonding with another water molecule. This hydrogen of alcohol is forming H bonding with water molecule, but this hydrogen is absent in ether because the ether structure looks like this, CH3O, CH3. Here, bacha, what is happening? There is no presence of hydrogen and hence this ether is a non-polar structure. Hence, it does not show any hydrogen bonding, only alcohols show hydrogen bonding. Okay, now let us move to this question. Who can answer this question for me? Dimethyl ether and ethanol. I'm asking you about two different things. Dimethyl ether and ethanol have same molecular weight, but boiling point of ethanol is greater than dimethyl ether because of what? Answer this question for me. I'm again looking at the chat box. Answer this question for me. Yes, answer this question for me. Okay, I first answer, Supriya's answer due to hydrogen bonding in alcohol. Supriya's answered C. Supriya, any more people want to answer this question? Does anyone else? Next answer I've received by Likhit, again C. Okay, Eleanor, Ronald has also answered correctly. Anurag has answered C. Tanishka has answered C. P.N. Rathish has answered C. Kumaran has answered C. Okay, okay, very good. So you understood the concept. Due to hydrogen bonding, it happens. Okay. Now what we're going to do, we've completed what are alcohols, what are the structural differences between phenols, alcohols, and ethers, and we've also talked about the physical properties of alcohols. Okay. Right now we're going to go one by one. We're going to study about alcohols first. We're going to study their preparatory methods as well as what kind of reactions they show right now. But before that, again, I have a very good news to share with you guys. And most of the students are already watching this, might know this, that if you like to learn with Vedantu and you're learning, okay, and if you like what we teach over here and you want to join our offline centers, want to go somewhere, meet the teachers in person, right? So there's a good news for you guys that Vedantu has opened its offline centers, right? And they are present in these cities, which you can see over here, right? In all these cities, and whatever city you belong to, whether you're from the south of India or the east of India or the west of India or even the top north from Jammu and Kashmir, till we are present, till Tamil Nadu we are present, right? So in all these states we are present, we have our offline centers, right? You can join them, and if you want to know more information, like when the class starts, what are the courses that you're offered, what is the duration of the courses, what will be the material that you are getting, right? And what is the frequency of the test series and everything, what are the teachers that are going to teach, then you can call or click on this number and get more information. Beta, again, I'm going to tell you that there's a link in the description box that you can go and click that link to know about all the centers. And this is a very good opportunity for you guys, right? Right, because you all are aware like what is the culture of Vedantu, how much we put in the efforts. You can obviously already see that the test series, that the lectures, the sessions, even with the offline mode, are going to be information filled with fun and creativity, right? And this is what the course structure looks like. You can have a look at it, and again, call on that number or even check out the link in the description box below. Okay? And also there's another good news, bacha. The good news is the famous teachers of Vedanta. You must be all familiar with Pulkit sir, the founder of Vedantu, right? Pulkit sir, and even her sir or Kia sir are going to meet you at all these offline centers on March 17, which is today, right? In Bhubaneswar on March 23, Janakpuri, Delhi on March 21, at Elpro Mall, PCMC, Pune, and in March 31st, Bapu Sabhanagar, Patna. So all these cities you can meet your favorite teachers if you belong belong to any of these cities, or you are nearby these cities and you can go and meet your teachers and grill them, right? Ask them for guidance. Ask them, sir, what to do. We see your faces every day. Now they will be in person and you can just grill them about whatever career options, anything, right? If you are preparing for JEE 2025, then what should be strategy? Sir, what to do, what not to do, what are the resources, and how did you achieve, how did you get into IITs, right? All these questions you can ask your favorite teachers on these specific dates. Chalo, you're from UPs, and bacha, in UP, you can actually go to either Delhi, right? I think for the UP people, Delhi will be nearer, so you can go visit Delhi to meet your teacher, right? Now we have all sorts of Vande Bharat Express running and all sorts of trains, all sorts of connectivity. You can at least do this much to meet your teachers, right? If you want, if you really, really want, otherwise, okay? And you can register now. The link is in the description box below. Let us again continue with the session. Chalo, chalo. This is all about the resources that I had to share. Now we're going to just jump right back in with the preparation of alcohols, right? What are we going to study? For example, how from the alkanes you can produce alcohols. So by producing alcohols, what are we doing? We're taking CH4 and you are making a CH3OH out of it. So what is actually happening? You are adding, there is an addition of hydrogen over here, isn't it? Addition of oxygen, sorry. There's an addition of oxygen in the product. Hence, what is happening? Oxidation is happening. So you took a simple methane and then you oxidize it with copper at very, very high temperature and pressure and you got a methanol. Number first, preparatory method. Number second, if you took a tertiary alkane, and then you try to oxidize it with KMNO4, which is a very, very strong oxidizing agent, you will again get a tertiary alcohol. This is the only way to prepare tertiary alcohol from KMNO4, right? How can you prepare tertiary alcohol from KMNO4? When you use a tertiary alkane. That is it. And from methane, how can you produce a methyl alcohol? By heating it with copper at a very high temperature and very high pressure. Very important methods. Let us move forward. Number first method, from simple alkane oxidation, we can prepare alcohols. Number second is alkenes. From alkenes, how can you prepare alcohols, right? So whenever, see, for example, this is an alkene molecule, okay? And to the alkene, we are actually adding a water molecule. How we are adding? To one of the carbon, we are adding H. To the other carbon, we are adding actually OH. So can you see that we are adding two of the atoms? Hence, what kind of reaction is this? This is number one, addition reaction. What kind of reaction is this? Addition reaction. And what are we adding to the double bond? We're adding a water molecule, H2O, right? Hence, this is a hydration reaction. And this reaction takes place in the presence of some acid. Hence, this is an acid-catalyzed hydration reaction. So, these are the three things that you must know about the addition of this. Okay, but and next thing is very important is the mechanism. Okay, how does this reaction actually takes place? This takes place through carbocation formation mechanism. What actually happens, bacha? For example, I took water in presence of acid, so I will form a hydronium ion. Number one step. Now what will happen? This was my alkene. Alkene is a electron-rich molecule. Why? Because these are double bond present. Double bond are electron-rich species because they have pi electrons in them. So these electron-rich species actually attack the H3O plus molecule, okay, and take a H from there. And take a H from there, and to which carbon the H will attach to the other carbon where the positive charge will come. Okay? Now can you see that there is a formation of carbocation over here? So whenever in any reaction, if there is a formation of carbocation, then bacha, there will for sure be the probability, be the process of rearrangement. Rearrangement. Meaning what? It means that if in the species there is a possibility or formation of tertiary carbocation or any stable carbocation, then that will happen. What is the order of stability of carbocation? I'm writing it here. The order of stability is the most stable carbocation is benzylic carbocation, right? Next is your allylic carbocation, okay? Next is your tertiary carbocation, next is your secondary carbocation, next is your primary carbocation, and the least stable is your methyl carbocation, okay? So this is the stability order of carbocations, okay? Everybody understood? So because the carbocation is forming, hence there will be the possibility of rearrangement. Last step is what? Last step is to this positive charge, again the water molecule attacks. Why? Because the water molecule has lone pair of electrons, it will attack, and your this kind of molecule will form in the step 2. In the step 3rd, again deprotonation will occur and your simple alcohol will be formed. Okay? Okay? Again, bacha, I want to tell you one more thing, that this addition of OH and H actually takes place through Markov-Nikov rule. Markov-Nikov rule. What does it say? It actually applies to unsymmetrical alkenes. For example, I took an alkene like this, CH3, CH double bond, CH2. I took an alkene and I am going to catalyze it with H plus and H2O. Okay, I want to do hydration of this. So what will be the product, bacha? What will be the product? The product, the major product will be CH3, CHOH. Here it will be CH3, right? So can you see that the OH gets attached at the most stable carbocation, or the OH gets attached at the carbon where less amounts of hydrogen are present. Can you see that on this carbon only one hydrogen is there? On this carbon there are two hydrogens. So the OH gets attached on that carbon where lesser amounts of hydrogens are there. This kind of addition is called Markov-Nikov addition. Okay, understood? So this happens with the acid-catalyzed mechanism of alkenes because carbocation formation takes place. Okay, okay. Yes, the negative part gets attached. Very good, Tanishka. You're absolutely right. The negative part gets attached to this carbon. Very good, Tanishka. Yes, let's move forward. Let's move forward. Now, for example, you have to predict the product of this reaction. So, I have given you an alkene and you have to show hydration in presence of acid. You have to tell me all possible products formed and also what will be the major product form. Again, rearrangement will be present in this situation. Try to do it in your notebooks and I will also help you solve in the board. Okay? Now, what was the very first thing? How will you approach this question? There is a possibility. As soon as you see this reagent, you have to see if there is a possibility of attachment of two species because hydration will happen. To one carbon, OH will attach. To the other carbon, H will attach. Right? So, number first is there is the addition of H. So, where does the H attach? So, there is the addition of H plus and OH minus. Correct? So, as soon as I see the alkene, I know that the alkene has so many pi electrons, hence it will attack the H plus over here. What will be the next step? As soon as it attacks, for example, this is C, this is C, this is C, right? Now, bacha, this is the molecule given to you. Now, there are two possibilities that either the H, the two possibilities are either the H can attach over here and the positive charge therefore will go over there. The next possibility is, bacha, once again I'm drawing the structure. The structure is C, 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 here C, here C. The next possibility is what? That the H attaches over here and the carbocation goes over here, right? Two kinds of possibility. Either the H can go over here or the H can attach over here. Okay? So there are two kinds of carbocations formed. Can you see here? Primary carbocation is formed and here it is a secondary carbocation. And we know that ma'am, secondary carbocation is always more stable, right? But again, can you see that in this molecule there is a possibility of rearrangement? What am I talking about? That I'm going to move this methyl group entirely to here, right? When I move that, what will happen? I'm again drawing the molecule. It is C, 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 and here it is C. I move this entire molecule to here, right? This CH3 molecule, and here the H was already attached. Now can you see the positive charge actually moved over here? Now can you see what is the degree of this positive charge now? This is a tertiary carbocation which is more stable. Hence can you see from secondary I formed a tertiary carbocation by 1,2 methyl shift. What is this called? This is called 1,2 methyl shift. Okay? For example, if this is the first carbon, this is the second carbon, right? So this is called 1,2 methyl shift. I formed a tertiary carbocation. Now this OH negative with the negative charge can actually attack this carbocation and form a structure just like this, which is C, 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 and here was the negative positive charge. So OH will come here, and here will be the C, C, and here it is the CH3. So this is the major product form. Major product form by the Markovnikov rule, by the rearrangement rule. Okay? The other product can either be this product or even the minor product. Okay? Now let us look at the solution. The major product is important. So this is how the minor product is formed, and this is how the major product is formed. That's all. It's everything that I just told you, but in better handwriting, and that's why I've included it here, so that when you get the PDF, the Telegram channel, you can look at it. Okay? But you understood the concept, right? Yes, bacha. Beta, it is not 1,3, it is 1,2 methyl shift. Okay? Okay? Chalo. Next, from alkenes. Number first, I told you. 1 second, let me switch off my phone. Yes. So number first method I taught you by alkenes was what? By alkenes, we were doing hydration using simple acid like H2SO4 or H3PO4. Simple protonic acid. What was the result? We just saw the result that in that, ma'am, carbocation formation was there, and also rearrangement was there, and also it followed the Markovnikov rule. All these things we need to keep in mind. The next, again, to alkenes, what we are doing? We're again adding, again doing with the what? We're again doing hydration only. Hydration only again we are doing. But here the reagent is changed. The reagent is Oxymercuration-Demercuration. The reagent is HgOAC2THF in the presence of water and NaBH4 and OH minus. Okay? What is the product formed in this case? The product formed in this case will again follow the Markovnikov rule. Again follow the Markovnikov rule, which is that the OH will attach to the carbon where lesser number of hydrogens are present. Can you see? To this carbon, less hydrogens are present, and the OH attaches here and the H attaches to the other carbon. Okay? But in this, what happens, bacha? There is no carbocation formation. There is no formation of carbocation, hence there is no rearrangement possible. In this, what will happen? Simple. To the double bond only, what you have to do, whatever molecule is given to you, you just have to look at that molecule, and to the carbon where lesser hydrogens are attached, attach OH, and to the other carbon attach H. That is it. There will be no carbocation, no rearrangement, nothing. Just by following the Markovnikov simple rule, you just have to attach the H and the OH. Again, how does the H and OH bacha attaches? For example, this is your alkene. Here CH and here it is CH2, right? So here, bacha, if OH attacks from the bottom, then the H will attack from the top. Remember this thing. So this is a anti-addition. What kind of addition is this? This is anti-addition reaction. Okay? If the OH attacks from below, the H will attack from the top position. So this is an anti-addition reaction. Again, very important thing that you should know. Follows the Markovnikov rule, and there is no carbocation formation. Okay? Next, solve this question for me. Again, a question for you guys. I'm giving you just 30 seconds to answer this question. Look at this alkene given to you. Oxymercuration-Demercuration produces which molecule among these four options? Answer the question for me. Answer this question for me. I'm again looking at the chat box. Yes, bacha. Yes. Supriya has answered A. Supriya has answered A. Tanishka has answered A. Sanjay has answered A. Very good, bacha. Very, very good. I'm looking for more answers. Sanjay again A. Remy Shetty A. Alan Ronald A. Anurag B. Bacha, why are you answering B? It says oxymercuration-demercuration. I just told you here M rule, Markovnikov rule is followed. Mark rule, I'm just gonna write Mark. Markovnikov rule is followed. What will happen? To the carbon which has lesser hydrogen, the OH will attach, and here the H will attach. Simple addition. Simple addition, hence the correct answer is A. Right? This is the only correct answer here. The correct answer is A, not B. Correct. Everybody else is right. Everybody else is right. And Anurag, did you understand the concept now? ठीक है चलो again another reagent. So number first reagent with alkene was we took an alkene and we did the hydration with acid and water, right? Number second was oxymercuration-demercuration. What were the pointers you need to remember? What is the reagent? It is something based out of mercury, right? And the mechanism followed the Markovnikov rule, but there was no carbocation, so no rearrangement happened. Now, third, very last hydration. Again, with another case, you can do hydration of alkenes. This is again a hydration mechanism. You're again adding H and OH to another carbon and H to another carbon, right? What are the reagents for hydroboration oxidation? It is B2H6 and your H2O2 and OH minus. What actually happens? This bacha happens through anti-Markovnikov rule. Anti-Markovnikov rule. Remember this thing, which means what? That the OH will attach now to the carbon which has more number of hydrogens. Okay? So to this carbon the OH attaches and to this carbon the H attaches, because only and only anti-Markovnikov rule is followed. I will tell you one interesting thing about the, okay, one more thing, that here again the addition is syn addition. Syn addition follows over here. Okay, another important, that the H, if H attacks from below, the OH will also attack from below. This is a syn addition. Okay, these are 2 pointers. Another thing I want to tell you is with the hydroboration oxidation, if the same molecule is given to you, but the reagent given to you is B2H6 and THF, and instead of H2O2, H2O2 is what? It is an oxidizing agent, right? H2O2 is a very good oxidizing agent. If instead of H2O2, some methanol or like some CHCl3 is given to you, some non-polar solvent is given to you, bacha, then what will happen? Then you will not attach the OH. What will simply happen, bacha? In some non-oxidizing reagent, if there are some non-oxidizing reagent, then what you will do? You will just make a normal alkane molecule like CH3, CH2, CH3. That is it. So only and only in presence of some oxidizing agent, the OH will attach. Okay? Otherwise, the OH will not attach if the oxidizing agent is not present. Okay? This kind of variations they do in your JEE exam. Hence, I'm going to teach you in every step. So just make a copy and write down these pointers that I'm telling you. Only these pointers will help you solve questions. Okay? Nothing else. Nothing. Just write down the main pointers. Okay. In the number first, acid-catalyzed hydration of alkenes, carbocation forms. Hence, rearrangement happens. Hence, Markovnikov rule is followed. What happens in oxymercuration-demercuration? Markovnikov rule is followed. No carbocation, no rearrangement. What happens in hydroboration oxidation of alkenes? Again, anti-Markovnikov rule. And Only after oxidation is done, the OH gets attached. Otherwise, the OH does not get attached. Okay? Chalo, let us move on to the next. This is the mechanism. Again, I'm not going to emphasize on the mechanism. Only thing you need to know is that with the BH3, the reagent that you are using, one by one, each hydrogen keeps on getting replaced by the alkene molecule. That is it. That is it. You have to study, you have to know. And okay, and anti-Markovnikov rule is followed. That is it. You don't have to remember the entire mechanism. Just know actually what happened. Just know, because that is it. What kind of questions can be asked out of this? I've already told you. Now next is again from alkenes. From alkenes, if you do their oxidation, what will happen? Right now we were doing hydration of alkenes. Now we're reading about the oxidation of alkenes. So how can you do oxidation? If you use cold, dilute alkaline KMnO4. Alkaline means in the presence of some base. Okay, it is called a Bayer's reagent. So in presence of Bayer's reagent, if you try oxidation of alkenes with water, what will actually happen? You will get a diol just like this. Simple. To this double bond, addition of OH and OH happens. That is it in the presence of KMnO4. Simple. This is called Bayer's reagent. What is Bayer's reagent? When KMnO4 is taken in cold dilute alkaline condition. Okay? Okay? Next is again from alkenes. We are again doing what? Again, I want to tell you one more thing. In the here, also in the presence of KMnO4 and also in the presence of K2Cr2O7. So these are very, very strong oxidizing agents. In presence of both of these things, diols are formed just like this. Okay? Next reagent is osmium tetraoxide. Again, we are forming diols from alkenes. First of all, we studied hydration of alkenes. Now we're studying oxidation of alkenes. So oxidation of alkenes causes what? Formation of diols, right? Now, for example, here, what is happening? Again, I forgot to tell you one more thing. Let us go back. Here, the addition is syn addition. Syn addition. Both the OH, if they either attack from the bottom side or the upward side. Correct? So this is a syn addition. Correct? Let's move forward. The forward is we're talking about osmium tetraoxide. Again, very good oxidizing agent. I took a alkene in presence of osmium tetraoxide and H2O2. Again, diols is formed. This is again a syn addition. Okay? Okay? Next thing that we're going to talk about is again from alkenes, we're doing oxidation only. But now we're using peroxy acid. Peroxy has 3 oxygens together. That is called a peroxy acid. Okay? Peroxy acid in presence of hydronium ion. What happens? Again, diols is formed. But here, anti-addition happens with peroxy acids. That is it. You have to know diols is formed but with anti-addition. Now next, alkenes is over. From alkenes, how we prepared alcohols is over. From alkenes, how we prepared alcohols is over. Now we're going to prepare alcohols from alkyl halides. So number first preparation is what? Which we studied even in the haloalkanes and haloadenes chapter, right? What happened was we took an alkyl halide and then we tried to react it with some aqueous base, right? So what will happen? This Br will go away, right? And it will be replaced by the OH minus ion, correct? These kind of reactions were called what? Nucleophilic substitution reaction, isn't it? We studied it in the last chapter. Nucleophilic substitution, the nucleophile attacks and it forms an alcohol. So one leaves and the other attacks. We're substituting one group with the other. Hence these are called nucleophilic. Why? Because some nucleophile is something which is negatively charged, is attacking your alkyl group. Hence it is called nucleophilic substitution reactions. Again, this reaction takes place in 2 ways. SN1 and SN2 mechanism, which we studied very, very clearly in our last chapter, isn't it? We studied this, isn't it? Beta, THF, somebody is asking, ma'am, what was THF in the last reaction? THF is just a solvent. That is it. You don't have to worry about it. THF is just a kind of organic solvent. Okay? Like how acetone is there. It is called tetrahydrofuran. Okay? You don't have to worry about all these things. Okay? Okay? Next, bacha. Next, we're talking about from Grignard reagent, what actually happens. From Grignard reagent means what? For example, you took a carbonyl group. So we talked about what happens with alkyl halides, and I've explained to you in very much detail what are SN1 reactions, what are SN2 reactions. If you don't know that thing, then you can go and look at the last lecture that we did. Right now, we are moving on to another preparatory method for alcohol. You take a carbonyl compound. It can be anything. It can be aldehyde or a ketone, right? And then you try to react it with the Grignard reagent. Grignard reagent is RMGX. Okay? Now, what is the property of a carbonyl compound? So, the carbon is actually delta positive because your oxygen is more electronegative in nature. Hence, it attracts electrons more towards itself. Hence, it becomes delta negative in nature, isn't it? This becomes delta negative. This becomes delta positive. Now, look at the Grignard reagent. The R, the alkyl group, which is attached to the metal, which is magnesium. So, magnesium will get a delta positive charge because it is a metal. Metals are always much more delta positive in nature, electropositive in nature. Always remember this, hence it will get a delta positive charge. Hence, because it is attached to an alkyl group, therefore, the alkyl group will get a delta negative charge. Everybody is understanding this point? Now, this delta negative can actually attack this delta positive carbon. Hai na? So, the R groups attach over here, and to the oxygen, the positive magnesium attaches to the oxygen and forms a adduct just like this. Okay, this is the first step, the formation of adduct. The second step is when I give water to that, then what happens? The OMGX goes away and the OH is left over here. So therefore, this hydrogen comes from the solvent that we are using, for example, H2O. If here D2O is taken, then D would come here, right? So this actually depends on the solvent that we are using. Hence, we have to know the mechanism from where the H comes from. This thing is clear. This is how you can form alcohols with Grignard reagent. Okay? Okay? Shall I move on to the next thing? Yes, this is again very good. This is again a addition reaction of carbonyl compounds. Very, very good, Alan Ronald. Okay. Chalo. Next is from Grignard reagent. Again, some more things are there. Some more things are, bacha, if with Grignard reagent you are using a methanol. If you are using a methanol, what kind of alcohol can you expect? Only with methanol, you will get a primary alcohol. Remember this thing. Only with methanol, you will get a primary alcohol. Okay? With other kind of aldehydes, you will always get a secondary alcohol. Secondary alcohol. Why? For example, this is another kind of aldehyde. To this aldehyde, this R will attach, right? This R will attach and form this kind of structure, and hence a secondary alcohol will be formed. And with ketones, bacha, what will happen? Ketones will always give rise to tertiary alcohols. So primary alcohols are only formed by methanol. All other aldehydes will actually give secondary alcohols, and ketones will give tertiary alcohols as products. The Grignard reagent is over here. So these are all the things you should know about Grignard reagent. Next is get ready to solve this question for me. I will again give you just 30-second question on your screen, which is, which of the following combination is suitable for the preparation of 3-methyl-2-butanol? I'm giving you 30 seconds, then I'm going to solve it for you. Okay, let me know the answer in the chat box. 3-methyl-2-butanol. Okay, so first answer I've received by Supriya A. Rupa has answered A. Sanjay has answered 2. Tanishka has answered A. Sanjay 2. Sanjay again has switched his answer to A. Okay. Okay, so I've received so much of answers. People are saying the answer is A. Chalo, chalo. Let us look at this question once again. The product formed is 3-methyl 2-butanol. Let us form the product. What is the parent chain? Butane. So butane molecule I'm going to form 1, 2, 3 and 4. Okay? And to the second number there is OH group. So to the second carbon I'm going to attach OH. And to the third there is a methyl group over here. Okay? So this is the product form. Now how to form the reaction from the product? So you have to know what actually gives us the methanol product. What actually gives us, what kind of alcohol is formed over here? Just answer that question for me. The alcohol is a secondary alcohol, isn't it? If the alcohol is secondary, it means that the reagent was, that the reactant was a aldehyde. What kind of aldehyde? For example, if this is the alcohol form, then the aldehyde was a C double bond O and H. So your acetaldehyde was one of the reactant. Number second is one, the acetaldehyde will react with another Grignard reagent. What kind of Grignard reagent? This is the Grignard reagent. The Grignard reagent is C, and to this C R, to this C, MgX is added. What is added? What is added? MgX is added. One second, here, MgX. So this is the Grignard reagent. So whoever answered, so everybody who answered anything other than this is wrong. The correct answer is acetaldehyde plus isopropyl magnesium bromide. The correct answer is C. Did anyone give the correct answer as C? Nobody. Nobody. Why, bacha? It is very easy to decode it. Look at what kind of alcohol is formed. Secondary. Secondary alcohol means we use some aldehyde. What aldehyde? Then just break the bond from here. So this is the aldehyde used. The aldehyde uses C double bond O and H. This is the aldehyde used. When I react this aldehyde with a Grignard reagent, what should be the Grignard reagent? This is the Grignard reagent, C, this one up. And then I attach the MgX to this carbon. That is it. Very easy. Just break the bond from between to one of, to where the alcohol group is attached, make it the aldehyde. To where alcohol is not attached, make it converted into the Grignard reagent. Simple reaction. Simple. So the correct answer is actually C. Did everyone understand, ma'am? Beta, how can you form with 2-butanol? 2-butanol will not give this reaction. If I, Tanishka is asking, ma'am, if I react 2-butanol with methyl magnesium bromide, you know what will be the reaction? What will be the product form? 2-butanol means what? This is 1, 2, 3 and 4. 2-butanol. And we know that ketones actually give tertiary alcohols. Do you remember this thing? This is a ketone given. Ketones will always give tertiary alcohols with RMGX. But we know that the product that we're getting is secondary alcohol. Hence, this can never be the option. You know? Only aldehydes give secondary alcohols. This is just in the very first look at it, you have to cancel this option because ketones only give tertiary alcohols. Okay? But only and only when you draw the structures with your hand in your notebook, only then these things will be clear in your head. Why is it clear in my head? Because I've done all the work. I've put in the hours, the effort so much. I'm already so much elder than you guys, first of all. Second of all, when I used to study these things, I used to form so many molecules. Only then it got fit in my head. Otherwise, it's very hard to fit in your head what actually happens with these molecules. You just cannot visualize everything. You have to draw with your hand, only then you'll be able to visualize the molecule. Okay? Chalo. Understood? Correct. Correct. Next is again a very interesting question for you guys. Which of the, achha, sorry, we just did it. Sorry. Next is from carbonyl compounds once again. From number one condition with the carbonyl compounds were using the RMGX, we made the alcohols. What are the other criteria from your carbonyl compounds to make alcohol? So first of all, look at the carbonyl compounds. They look like this. C double bond O, right? They look like this. Now I want to convert them into alcohols, which means what? To this CO, I am adding one H over here and the other H is added over here. Can you see that here hydrogen is getting added to the carbonyl group, both to the carbon and to the oxygen. Okay? This is how you can convert your carbonyls to alcohols. So what is actually happening? Addition of hydrogen, which means that reduction is happening. Reduction. Okay? So whenever you want to convert carbonyls to alcohols, what you are actually doing, you're performing reduction reaction. Correct? Now, first of all, by reduction of aldehydes and ketones, by what is happening? For example, you took a aldehyde and you took a ketone. Okay? And you are using any reducing agent. We're going to talk about different kinds of reducing reagents one by one. So what I'm doing, I took aldehydes and ketones and I took some of the reducing reagent, and then with aldehydes, what I'm getting your primary alcohols. Can everybody see? I'm getting primary alcohols with aldehydes. With ketones, I'm getting secondary alcohols. How? By using the reducing reagent. So when with carbonyls, I was using the Grignard reagent. With aldehydes, I was getting secondary alcohol. With ketones, I was getting tertiary alcohol. But with the same carbonyl, if I'm using a reducing agent, then with aldehydes, I will get a primary alcohol. With ketones, I'll get a secondary alcohol. And this trend will be followed with every reducing reagent that I'm going to tell you about right now. Okay, understood this basic thing? Next thing is, first kind of reducing agent which everybody should be familiar with is H2 in presence of palladium, platinum or nickel, right? Here what happens? Simple with aldehyde, simple primary alcohol is formed. Okay? And with ketone, what will be formed? Simple secondary alcohol will be formed. Okay? Next kind of reducing agent, very, very common, is NaBH4, which is sodium borohydride. Very important kind of reducing reagent. What you have to know about it, bacha, it only reduces the carbonyl group, whether it is aldehyde or whether it is ketone. It will not reduce your double bonds. It will not work on double bonds. It will just work on your aldehyde or ketone group. And when you're using NaBH4, it gets converted into alcohol, which is primary, because we have used the aldehyde. With aldehydes, we will get a primary alcohol just like this. Okay? With NaBH4, is this thing clear? Next reagent is LiAlH4, which is another very important kind of reducing reagent. This is a very, very strong reducing reagent. Remember this. Very strong reducing reagent. If we have to compare between LiAlH4 and NaBH4, this is a very important variety of questions asked in your exam. Difference between LiAlH4 and NaBH4. What one reagent will reduce, what the other reagent will not reduce. Important kind of question, right? So LiLH4 is a strong reducing agent. It will reduce the aldehydes, the ketones obviously, but it will also reduce ester, carboxylic acid, acid chlorides and even carboxylic acid. Okay, it is repeated twice. And even the carboxylate salts. So it is reducing every derivative of carboxylic acid, whether it is a acid chloride, ester or even their salts. Okay? For example, we took an acid and we're trying to convert it into alcohol. Acids with LiAlH4 that gets directly converted into primary alcohols. Okay? But also remember one more thing, bacha, ki LiAlH4 is actually an expensive reagent. It is very, very expensive. When you go to market, it will cost you a lot of money, right? So what to do? So we have to replace this LiAlH4. If you want to produce so much of alcohol from acid, then LiAlH4 will actually increase your budget, right? It will actually make you like give all your money to just LiAlH4, then what profit you're going to make in the industry. And what actually people do, bacha, is they actually first convert the acid into ester, okay, by using the esterification reaction, and then use the hydrogen with some catalyst and produce alcohols. So people generally in laboratories try to avoid LiLH4 because it is a expensive reagent. Hence, again, what do? They actually convert acids to esters, and then esters can be can be reduced by hydrogen and catalyst and form a alcohol product. ठीक है? ठीक है? Yes, bacha, this is useful even for EAPCET because the course remains same. The course is same no matter what exam you are taking. Hi Parmeela, good afternoon, good afternoon. Okay, now we're going to just compare between these two reagents which is asked so many times in your exam in various formats. It will be asked. Once you start doing the PYQs, you will realize the importance that I'm again and again mentioning about these reagents. For example, look at NaBH4 and look at LiLH4. What is the differences between the two? So, bacha, aldehydes. What aldehydes do, bacha? They actually can reduce your primary alcohol. Aldehydes, so we are talking about they convert aldehydes to primary alcohol, right? They convert ketones to secondary alcohol, and NaBH4 can just reduce these two groups, while your LiLH4 can even reduce esters, carboxylic acid, amides, and nitriles. So it converts esters into primary alcohols, carboxylic acid also into primary alcohol, amides into amines, and nitriles into primary amines. Okay? Amide is what? Amide is C double bond O NH2. So it converts C double bond O NH2 into CH2 NH2, which is the amine molecule, and it converts nitriles. Nitriles is C triple bond N. It converts nitriles into primary amine, which is CH2 NH2 once again. Okay, so understand these things. Understand these things. Okay? Okay? Shall I move on to the next part? Okay, Supriya? Chalo. Now again a question on your screen. Very good questions for you guys. You're going to learn even more concepts with these questions. Which of the following reagent would carry out the following reaction? What do we have? We have a ketone over here, and from this ketone we are converting it into a secondary alcohol. Can everybody see that? Can everybody see that? We're converting ketone into secondary alcohol. But the OH here is this, and here the D is attached. So what do you think should be the reagent used? Just try to solve this and then I will tell you the approach, how to actually approach this question. Okay, try to solve. So what actually happens with ketones? So, bacha, when I try to reduce ketone, I'm doing what? I'm reducing the ketone to the alcoholic part, right? So, bacha, what happens? Whether you are taking LiAlH4 or whether you are taking NaBH4, doesn't matter. In both of these reagents, we are going to use these reducing reagents with some solvent, right? With some solvent. Okay? Any solvent. It could be water, it could be D2O, just like here D2O is there, right? So what actually happens, bacha? What actually happens? For example, one of the H attaches here and the other H attaches here, right? Right? So, bacha, the H that comes from here, remember this thing, the H that attaches here actually comes from the actually comes from the NaBH4 or your LiAlH4, right? And the H over here actually comes from your solvent. Just write this. This H comes from the solvent, the H that attaches on the oxygen, while the H that comes from these LiLH4 and NaBH4 attaches over here. Okay? Understand this funda. Now let me know what is the correct answer out of these options. What do you think is the correct answer? D is not the correct answer, but D is not the correct answer. Okay, try once more. What I am saying, the hydrogen that attaches to the carbon comes from the reducing reagent, while the hydrogen that attaches on the oxygen comes from the solvent that you have taken. It can be a methanol solvent, it can be a D2O solvent, right? Now answer this question for me. I'm again looking at the chat box. Okay, A answer I've gotten by Likhit. No, yes. First answer was given to me by Sanjay, then Likhit, Then Kumaran, right? Then Tanishka also A. Very, very good. Very, very good, right? Because why is it happening, Bacha? I'm again going to tell you a very interesting phenomena. A very interesting phenomena. For example, this was the structure given to you. This was the structure. This. This was the C double bond O. Here is the CH, right? Now, what is actually happening? How? I will tell you a trick where you don't have to just rectify whatever I've told you. You don't have to do any rectification. Organic chemistry can be understood with concepts, right? Most of the organic chemistry is just concepts. Here, what is happening? Here, what is happening? The oxygen here gets a delta negative charge, isn't it? And the carbon over here gets a delta positive charge. Everyone agrees to that because oxygen is more electronegative, it gets the delta negative. So the carbon will get the delta positive charge. Is this thing clear? Now with the reducing agents like LiAlH4 and NaBH4, what are the properties of this reducing agents? What is the name? Just look at the name. This is called lithium aluminum hydride. This is sodium borohydride, which means what kind of hydrogens they are giving? They are giving hydride hydrogen. Hydride means H minus molecule they are providing. This is called the hydride molecule, right? Hydride is H minus ion, right? And also you can understand it by this concept that lithium and sodium are metals. And metals will be electropositive in nature. This will always be delta positive, delta positive. And also aluminum is also a metal. Okay, so this will also be delta positive. Hence, hydride, hydrogen will always get the negative charge in this. Okay, so you will get a hydride H minus ion. So where will this hydride attack? Obviously to the delta positive carbon, right? So to the carbon, the hydrogen that we're attaching to the carbon will come from the reducing agent, right? And the hydrogen that attaches to the oxygen will obviously come from the solvent. This thing is clear to everybody? This thing is clear to everybody? Okay? Okay? Chalo, next. Let us do the next. This question is again on your screen. Which of these reagents would accomplish the following reduction? Again, some kind of reduction is given to you. What kind of functional groups are present? A nitrile functional group, a carbonyl functional group, and a alkene functional group is present. Okay? From this molecule, you are getting a molecule which is just the reduction of the carbonyl group is happening. So, which reagent was used and what is the solvent used to convert this molecule into that molecule? Answer. 30 seconds. Again. Chalo. Tanishka Pandey has given me the very first answer. A. Sanjay A. Okay. NaBH4 in satiation. Very, very good. Both of you are right. Uma Subhash has given me A again. Very good. Then Vemi Shetty has given me A. Supriya A. Likit A. And Kumaran A. Very good. The answer is A. Because only NaBH4 can only reduce this molecule, which is carbonyl. LiLH4 can convert all of these. LiAlH4 cannot convert this double bond over here, but it can convert this nitrile into primary amine. Okay, chalo. Next question once again. Okay, chalo. Do this question for me. In the following reaction, B and C are respectively. B and C are respectively. Yes, Bacha, this is an extremely high weighted chapter. So many questions were asked even in your January attempt. Okay? Yes. And what is actually high weightage? In organic, if you see, everything is so interconnected. I cannot tell you this is a very, very higher weighted chapter, this is a lower weighted, because the reaction mechanisms, the reaction processes followed is just the same. And the kind of question asked in your JEE are actually very simple, plain reagent based questions, right? So whatever reagents are keep on repeating in every chapter, those reagents are actually very important. And you keep on learning one extra thing about those reagents in every chapter that you study. Correct? Chalo. Who can answer this question? Again, I'm going to look at the chat box. I haven't received even one answer yet. Why is that the case? Why is that the case? Again, you have two kind of reducing agent, NaBH4 and LiAlH4. and you have what all functional groups are present. First, identify the functional groups. Can you see that this is a carbonyl functional group? Can everybody see that? This is a carbonyl functional group, and we know that both of these reagents can reduce the carbonyl into alcohol. This is a ketone, so secondary alcohol will be formed, correct? So with both of these reagents, the OH will come, right? The OH will come over here. So first step will be with both of these, bacha, the OH, secondary alcohol will be formed over here. Here the oxygen was present and here double bond O was there. Okay? This is going to be common in both the cases, right? Right? Now, identify the another functional group. What kind of functional group is this? Can you see that this is some kind of ester, right? This is a intramolecular ester. Within a molecule, there is a ester is present, cyclic ester, or you can say, but this is a kind of ester molecule. And we know that NaBH4 can only reduce can only reduce this structure, carbonyl structure. Hence, the C option should be this. This is the C option because it can only reduce the carbonyl group, cannot reduce the ester group. Hence, the C option, look at the C option. The C option is this. This is over in one A option and B option. So, between A and B, we have to choose one answer, correct? So, this is the C option. Now, look at what can happen with LiAlH4. What can happen with LiAlH4? Okay, I am rubbing this part. I am rubbing this. Now, next is what can happen with LiAlH4. So, I am again drawing this structure. Sorry. Yes, this is the thing, right? Yes. So, thing is, here it is the OH molecule, correct? Here it is this, and here it is this, and here it is this. Is this structure clear to everybody? This is the ester molecule, right? In ester, what happens? There is again a formation of a primary alcohol, right? So, one of the alcohol will be formed over here, and the other, what will happen? The bond will break from here, and the other alcohol will form over here, which is this OH over here. So, this is the structure for bacha, the B option. The B is this. B is this, right? So, where do you think this structure is formed? Where do you think this structure is? This, okay? So, the correct answer is A. The correct answer is option A. Yes, Likitha. Yes, Alan Roll. The correct answer is A. Very, very good. You understood? The ester gets reduced into primary alcohols in both the cases, and in LiH4, NaBH4 is only able to reduce the carbonyl compound. Very good. Next question on your screen. Once again, so you have been given a compound and the reducing agent given to you is LiAlH4. Now predict the product. Now we have discussed every kind of possibility. Now you should be able to answer this question. I'm again giving you just 30 seconds to solve this. I'm looking at the chat box. I'm looking at the chat box. Give me the answer. Answer, bacha. Answer. Very easy once again. First, identify the functional groups present. Identify the functional groups. First answer I have received by Sanjay is C. Sanjay has given C answer. Ashwant has given C answer. Uma Subhash has given C. So, once somebody gives one answer, now everybody copies this, or you are actually calculating the answer? Remy Shetty has given A answer. Okay, Remy Shetty is not right. Alan Ronald has given C. Likhit C. Kumaran S. Hill has given C. Okay, very good. I've received, most of the people have given me C answer, correct answer. Chalo, with Li, first identify the functional group. This is a ketone functional group. So, here the OH will come. Okay, so the correct answer is, I'm again drawing this molecule over here. Okay, so here OH will come. I've attached the OH. This carbonyl gets converted into secondary alcohol. This is a ketone molecule. Now, can you see this? This is the aldehyde. Aldehyde. will again gets converted into OH molecules. Here it will come CH2OH. Okay? Okay? But here I will try to write the molecule as it is given in your here. So it will be C and here it will be OH molecule. Now here what kind of molecule is this? This is again a ester molecule. So what will happen? This bond will again break from here and two kinds of primary alcohols will be generated. One it is CH2OH, right? So where do you think this answer belongs to? Okay? So the answer, the correct answer seems to be C. Can everybody see? The C is the correct answer. Most of you have given the correct answer. Very, very good. Let's move on to the next question. Now we are moving on to another kind of reactions which is called the dehydration reactions. So first of all, what we did, we took an alkene and we were trying to hydrate the alkene. Remember hydration reaction. I took an alkene and then I tried to hydrate it with acid and water, acid-catalyzed mechanism, with Oxymercuration-Demercuration, with Hydroboration-Oxidation. We were trying to hydrate the alkene to form the alcohol product. Now we're doing reverse. Now we're talking about the reaction of alcohols. So what can I do? I took an alcohol. Now I'm dehydrating. Now I'm doing the dehydration, means removal of water molecule, removal of H2O molecule in the presence of acid, and the product that I'm getting is a alkene product. Remember this thing. Okay? And in which of the cases dehydration can be carried out? It can be carried out in the presence of protonic acids like H2SO4 or even H3PO4. Okay? And even non-protonic acids like Al2O3 and P2O5. So with all these acids, whether it is a Lewis acid or a protonic acid, in presence of acid, you took an alcohol. In presence of any acid, you get a alkene. Okay? You're getting what, bacha? You're getting a dehydrated product. And this is also called intramolecular dehydration because within the molecule, the H2O molecule is getting eliminated and a double bond is formed instead of that. Okay? Is everybody okay with this thing? Okay? Okay? Next is bacha, for example, what is happening? I took a secondary alcohol. So this was the reaction with primary alcohol. With primary alcohol, you get a simple alkene. With secondary alcohol, there are possibilities of getting two kinds of alkenes, right? Two kinds of alkenes are what? For example, yes. So this kind of alkene can be formed, and with tertiary alcohol, again the alkene is formed. And ease of dehydration, bacha, follows the order. Tertiary is more than secondary, is more than primary. Why is that the case? Because again, in this case, what happens? Carbocation mechanism takes place. Carbocations are formed, right? And again, for example, if an unsymmetrical alkene is given, no, it is not given. So, sorry. Yes. So, I'm just going to teach you about the unsymmetrical alkene. For example, if this kind of product is there, CH3, CHOH, and here it is CH3 molecule. Okay, no, not this. One second. CH3, CH2, and here it is CHOH. Okay, this kind of molecule is given to you. Or any unsymmetrical, how can we form an unsymmetrical alkene? Why am I not able to form? Yes, we will take a butene. One second. Yes, we take a C for example. We take a CH3, CH, here is the OH, here is the CH2, and here is the CH3. So we took this kind of alcohol from here. And on this alcohol, I'm doing its dehydration in presence of acid. So what will happen? One of the hydrogens can go away from here, or either the hydrogen can go away from here, right? It has two possibilities. Either this can go away or either this can go away, right? So there is a formation of two kinds of alkenes. It can be CH2 double bond CH, and here it is CH2 CH3. This is one kind of alkene. Another is CH3 CH double bond CH CH3. See, this is another kind of alkene, right? Two kinds of alkenes can be formed, but what is the major product, bacha? The major product is the more substituted alkene. More substituted means to the double bond. The double bond should be surrounded by more molecules. Can you see? Here the double bond is surrounded by just one methyl group, and here this structure is there. But here the double bond is more substituted. So this rule, this will be the major alkene form, and this rule is called the Sedgwick rule. What it is called? It's called Sedgwick rule. So more substituted, which means the double bond should be in the middle, right? So more substituted alkene is a stable product. This is called the Sedgwick rule. Okay, everybody is understanding this? Yes, second one is major. Correct, correct, correct. Chalo. Chalo, next, we already did this. Now let's move on to the next question. By dehydration follows 3 steps. What is this? Why was I saying that tertiary alcohols show ease of dehydration, then secondary, then primary? It depends on their mechanism. Once again, look at the mechanism. The mechanism follows 3 steps. Number first is the formation of protonated alcohol. Number second is the formation of carbocation again takes place, and then the alkene is formed. For example, this was the alcohol. This is the tertiary alcohol over here. And in the presence of acid, what will happen, bacha? In the presence of acid, this H plus is attacks over here, है ना? And this forms a hydronium ion just like this. So H2O plus will be formed over here. So because this is a very good leaving group, this leaves. And after this leaves, what happens? Tertiary carbocation is formed over here. So when tertiary carbocation is formed, then there is again a possibility of 2 kinds of alkenes, and we know that more substituted alkene, which is this, will be the major product. So what do you have to actually know from the mechanism? That there is a formation of carbocation, okay, and there is a formation of protonated alcohol, right? So this OH here gets protonated by this H plus ion, and then it leaves because it becomes a very good leaving group. After it leaves, it gives the positive charge, transfers the positive charge to the carbon, and therefore, because tertiary carbocation is more stable, hence what happens? Tertiary alcohols are easily reduced to alkenes, then your secondary, then your primary alcohol. Correct? Let's move on to the next stuff. So this is how the reaction mechanism takes place. Here, this is the acid given. This will give out the H plus ion. This OH will attack the H plus and forms the hydronium ion, which is a very good leaving group. So this leaves, leaving behind the positive charge on this carbon, right? Now, when the positive charge is on this carbon, this is again a primary kind of carbocation. But can you see that if the carbocation moves over here, it will become a tertiary. Can everybody see this can become a tertiary carbocation? So it definitely does that. And then what happens? Hydride shift happens for it to form a tertiary carbocation. And after the tertiary, so what are we actually seeing? That rearrangement is possible. Rearrangement is possible with the acid dehydration mechanism. So after that, what will happen? Again, the proton will be taken away by the water molecule, and the alkene product will be formed. So what are the key takeaways? That carbocation is formed, and hence anywhere if the carbocation is formed, the rearrangement will definitely take place, which means what? If there is a possibility of a higher carbocation to be formed, like secondary or tertiary, it will be formed. And after the formation of carbocation, the double bond will attach according to that, following the Sedgwick rule. Okay? Chalo, next. Again, for example, look at this example over here. This is a secondary alcohol given to you. I just explain it to you, right? After this alcohol is formed, what are the possibilities? That this OH will go away. It can take either the H from here, or it can take either the H from here, right? In both the cases, what happens? This is the major product, 80% is formed. This is only the minor product is formed, because according to the Sedgwick rule, which I just explained it to you, right? I just explained it to you. Next is if you are using a non-protonated acid, for example, Al2O3. If you are using a non-protonated acid, now there is no proton, therefore, no carbocation is formed. If there is no carbocation formation, then no rearrangement will also be there, right? no carbocation, no rearrangement. Okay, but what will happen? But the Sedgwick rule is applied, which means more stable alkene will be formed, but there will be no rearrangement because there is no carbocation. But with the protonic acid like H2SO4 or H3PO4, there was a possibility of rearrangement. Here, if Al2O3 or P2O5, any kind of Lewis acid is given to you, which does not give out protons. Non-protonic means H plus is not given out, right? It does not have any H plus, hence it is a non-protonic acid, right? So this will actually follow these rules. ठीक है, चलो चलो next. Yes, bacha. Protonated means there will be presence of a proton. Proton is hydrogen. ठीक है, hydrogen is another name for hydrogen is proton. Remember that. ठीक है, H plus. H plus is a proton. Now look at this and tell me the reaction. Tell me the answer to this question. The most probable product in the reaction given below. So you have a cyclopentane and alcohol is there, and you are trying to heat it in presence of a protonated acid which will give out H plus ion. So what will be the final product? Try to draw it. Try to remember ki here again one more thing can happen, which is ring expansion. Remember that thing. Ring expansion can happen. This is a 5-membered ring. If it has the possibility to get converted into 6-membered, it will get converted into a 6-membered ring. Again, very important thing to understand. Just remember this thing. Just remember this thing. Yes, bacha, then what will be the reaction mechanism? What will happen? So what is the first thing that happens? What was the first thing that happens? That your OH, because oxygen has what? Let me erase all the ink on slide and then we'll begin again. Oxygen has lone pair of electrons, isn't it? Oxygen has lone pair of electrons. So always remember oxygen has lone pair and the acid will give out H plus ion. So the lone pairs will now attack the H plus, right? After the lone pair attack the H plus, what should be formed next? What should be formed next? Something, a compound like this, O, and here it is the H, here it is the H molecule, and it will get a positive charge, and here again this. Okay? So what will happen, bacha? What will happen? This is not the molecule. Let me draw it clearly. Let me draw it clearly. Understand it step by step. I'm again drawing this pentane molecule over here, cyclopentane, right? Here is the methyl group. Here is this, and here to the OH, the H plus will attack and it will form a protonated hydronium ion. This is a very good leaving group, so this will leave. This will leave. If this leaves, what will be the next step? The next step will be formation of carbocation over here. Here the carbocation will be formed. Okay, everybody can see this. Everybody can see this. Now what is the next step that's going to happen? Now remember that ring expansion can take place because this is a 5-membered ring. It can get easily converted into 6-membered because 6-membered are even more stable rings. Now how to do ring expansion, I'm going to explain it to you because same example will not be repeated, but the concept will be repeated. So you have to understand how ring actually expands. So understand that this is, for example, this is a box and this is the lid of the box. This bond is lid of the box. Now what can happen? This bond, I'm opening this bond and I'm trying to connect it over here. Okay, I'm opening this bond and I'm trying to connect it over here. Then what is the structure form? I'm again forming this cyclopentane ring like this. This was the ring before, isn't it? This was the ring before. Now what I'm doing, I'm trying to, here it was this, here it was this, and here it was this, right? And here I just formed a line like this, right? This is the structure form, and here again a methyl group is attached. Here again a methyl group is attached. Now what will happen to the positive charge? What will happen to the positive charge? So can you see, to this carbon, I attached to this here. Hence, the positive charge will go to this carbon. The positive charge will go to this I attached over here. So, the positive charge will come on to this carbon. Okay? Will come on to this carbon. Now, can you see a six-membered ring is formed? So, I will form, this was a puckered ring that I formed. So, I will form a very good six-membered ring just like this. And here, one methyl group was present. Here, the second methyl group was present. Here, the positive charge was present. Now, again, hydride shift can take place, isn't it? Now, if the hydride shift can take place, then this positive charge can move over here, isn't it? After the hydride shift. So, after this is a secondary carbocation. After shifting the positive charge, what can actually happen? It can get converted into tertiary carbocation, right? This is a tertiary carbocation. Now, next step is here the double bond will take place. Now, here the double bond will attack over here just like this. After this positive charge goes away. So this is the final product that you're going to get from this reaction. Beta 7-membered rings are not stable. Just remember, only two kinds of rings are stable, which is a 5-membered and a 6-membered ring. Okay? And 6-membered rings are the most stable rings. Before that, like 3-membered, 4-membered, and even 7-membered, 8-membered, both of these, before these and after these, are the unstable ring. Only two rings are stable, 5-membered and 6-membered, and 6-membered are the most stable ring. Correct? Understand this thing. Okay? All other kinds of rings are not stable due to their bond angles. There is so much angular strain in them, hence these are not stable. Okay? So the final product I've already told you. Look at here. The final product formed is this. We already understood this. Now, you have to answer this question for me. Understood that part, everybody? Now, which of the following alcohols is dehydrated most readily with concentrated H2SO4? With concentrated H2SO4. Okay? Very good, Jeevan is saying my answer was correct. Very good, Jeevan. Yes, due to bond angle strain. Answer this question for me. Which of the following alcohols is dehydrated most readily with concentrated H2SO4? Who can answer this question for me? First answer by Sanjay B. Sanjay B, Jeevan B. Okay, very good, very good. Chalo, only two people are going to answer. What about the rest of you? Answer me, Bacha. What about the rest of you? Yes, Bacha, tertiary, stable and secondary. Yes, Femi Shetty. Likhit C. B due to carbocation. Very good, Jeevan. Jeevan has grasped the concept. Jeevan has grasped the concept. Likhit, you are not right this time, Bacha. Likhit, you are not right. So, Bacha, what is happening with concentrated H2SO4? Again, you're forming a carbocation. Remember this thing. After this OH goes away, after I remove this OH, positive forms over here, isn't it? After this OH goes away, positive carbocation forms over here. After this OH goes away, positive here, and again positive carbocation over here, right? In all these cases, carbocations are formed whenever we are using an acid-catalyzed mechanism. Okay? So now look at the stability of the carbocation. Okay? This is a benzylic carbocation, hence this is stable. We know that. But can you see that here OCH3 group is attached? OCH3 group, what is the criteria of OCH3? That it can give its electron in resonance in the benzene ring, right? It is increasing the electron density in the ring. OCH3 is an electron donating group. It increases the electron density. Hence, it is stabilizing the positive charge, right? I'm positive. I want to become stable. How will I become stable? Remember, only neutral molecules are stable. If I'm positive and I'm getting a negative charge, I'm actually becoming more stable. So, this is the most stable molecule over here. NO2 is a electron withdrawing group. It is withdrawing the electrons from the benzene ring. And you have already made a positive charge. So, if I'm already positive and you're taking more and more electrons from me, then you're making me more unstable. This is the most unstable species. And similarly, Chloro group is a deactivating group of the ring. Deactivating means something which takes away the electrons from the benzene ring, but we want to increase the electron density because there is a positive charge, right? Positive. In order to stabilize the positive charge, you need to give electrons to make the positive more stable. Hence, B is the correct answer because only here it has the ability to increase the electron density in the ring, hence stabilizing the positive carbocation form. The correct answer B given by so many people. Very good. Correct, Jeevan. This shows the plus M effect or plus R effect. Very, very good. Very, very good. Correct. Let's move on to so this is the reason explained to you. This is the most stable carbocation and that one is the least stable because it is the electron withdrawing group. Correct. Let's move on to the next question. Next question. Who can answer this question for me? The product of the following reaction is, so you've been given an alcohol and you've been given again a protonic acid. It has the ability to give H plus ions, isn't it? Now what will be the reaction? What will be the product form? Answer this question for me. Yes, answer this question for me. Yes, Suhaib, you're right, right. Chalo. Answer this question for me. Again, a very, very good example. Just to check whether you have understood the concept or not. Answer this question for me. I'm giving you 30 seconds once again. Very easy question. We have done similar questions. First answer by Vemi Shetty B. And by Suhaib has given me the correct answer. Even you're not right. This is again a protonic acid is used. Protonic acid giving away H plus means carbocation will be formed. If carbocation is formed, there is a possibility of ring expansion because there is only a 5-membered ring given over here. 5-membered can convert into 6-membered ring. And after the 6-membered ring is formed, it will get converted into an alkene. So Sohaib is definitely right in this case. Then Sanjay is also right. B is not the answer, bacha. Sanjay, you are right. Anurag Singh is also right. Kumaran S. Hill is also right. Game over Tamil. Hi, welcome back to the session. You are also right. Game over Tamil. Why? Let us see if I've attached. Yes, I've attached the solution. Look at the solution with me once again. This was the alcohol given to you. In presence of acid, what will happen? This oxygen will attack this proton. After it attacks this proton, what will happen? This OH leaves. After this OH leaves, it leaves behind a carbocation just like this. Okay? Now what can happen? To the box lid will open. The box lid of the cyclopentane will open. After it opens, what happened, bacha? After it opens, this carbon is opening. So this carbon, this is not carbon. After this lid is opening, what is happening? This is forming a bond with this CH2 molecule. Can everybody see? This forms a bond with this CH2 molecule, hence the positive charge actually comes over here. Okay? After this cyclohexane is formed, on one of the carbon, positive charge will come, and then what will happen, bacha? What will happen? Again, deprotonation will happen and the alkene will be formed. After the deprotonation happens, alkene will be formed, which will be a cyclohexene. Okay? Somebody is asking how to know when ring expansion occurs, ma'am. So whenever you've been given a 4-membered, 5-membered ring, right? You can convert them into higher membered, like 5 and 6. Always remember, if there is a possibility of conversion to either 5 or 6, only then do the ring expansion. If there is a 3-membered ring given, just like this, 3-membered ring given, here is a CH3 group given. Okay? But these will rarely be asked. But always remember one more thing. Yes. So only if there is a possibility of converting into 5-membered into 6 or even like 4-membered, just like this, CH2, CH3, and here the OH is present, right? So here again there is a possibility of converting this into a 6-membered ring. Okay, tell me one more thing. I'm going to ask you a very nice question. With that question, many things will get clear to you guys. 1 second. Yes. So this is a uh, uh, cyclobutane molecule. The molecule is CH2CH2OH, right? And the other molecule given to is again cyclobutane, and here it is CHOH, and here it is CH3 molecule. Okay. Now in both the cases, I've reacted it with H plus. Here also I've reacted it with H plus. Okay. So after I've reacted it with H plus, what will happen? The OH plus will go away from here. The OH will go away from here. Okay. And what will happen? A carbocation will be formed over here. The carbocation will be formed over here. Now, in which case ring expansion will happen? Answer me this question. In which case ring expansion will happen? In both the cases, okay, I'm writing it A and I'm writing it B. Answer me in the comment section. In which case ring expansion will happen? Will it happen in the A molecule? Will it happen in the B molecule? Or will it happen in both the molecules or none of the molecules? Answer me this question, everybody. Everybody answer me this question. Second, Sanjay's answered second. BB, very good. You have understood the concept. Understood. Here, bacha, can you see the ring is so far from the positive charge, right? So here there is no possibility of ring expansion. Only in the below case, what can happen? The lid can open and it can attach to this positive charge, right? So first, it will open and form a cyclopentane ring, just like this. It will form a ring just like this. Cyclopentane will be formed. A cyclopentane will be formed, right? And after the cyclopentane, here is the CH3 and here the positive charge will come. Now again what can happen? Now this CH3 this lid can again open. No, this cannot open because the positive charge came over here. So no, now no more expansion can take place. Because for expansion to take place, the positive charge has to be on the molecule over here. Now the positive charge has actually transferred to the cyclopentane ring. So now no more expansion can take place. The expansion has stopped now, right? If the positive charge instead somehow the positive charge was on this CH3 molecule, then this expansion can again happen and a cyclohexane ring can be formed just like this. Okay, everybody understood this point? Chalo, let us move to the next dual nature of alcohols. Another kind of question. Another kind of reactions of alcohol. Okay, so I've been speaking since 2 hours now. I just realized since 2 hours. Hydride shift then ring expansion. Correct, correct, correct. Yes, Suhaib, if in first there is a possibility, you're very correct, Suhaib. In that, what can happen? There can be rearrangement, and after rearrangement, ring expansion can happen. Correct, correct. Very good, very good. Chalo, chalo. Dual nature of alcohols. Now we're going to read about the reactions of alcohols. Number one reaction of alcohol was dehydration. After dehydration, what was happening? Alkenes was taking place, and also we learned a little bit about ring expansion in that. Next is dual nature. What do I mean by that? Look at the molecule of alcohol. Alcohol molecule is ROH molecule, right? This is the alcohol molecule, correct? Now in alcohol actually can show two kinds of reactions. The two kinds are either the ROH bond can actually, the OH bond is actually breaking. What bond? OH bond. If OH bond is breaking, it means what? It is leaving behind the RO minus species, isn't it? The RO minus species then acts as a very good nucleophile, isn't it? This acts as a very good nucleophile. Hence, it shows many nucleophilic reactions, correct? So, this acts as a nucleophile as well. But the other kind of bond breakage is even in the ROH, what can happen? This bond can break, the RO bond. If the RO bond breaks, then what is the product form? The product form is the R plus product, which is a kind of electrophile. So it will also give electrophile kind of reaction. Electrophile. Okay? So can you understand this thing? So when the OH bond is breaking, the alcohol is behaving as a nucleophile. But when the RO bond is breaking, it is behaving as a electrophile. Understand, this is why I said that this is a dual nature of alcohols. Two kinds of reactions will be shown, where first of all OH bond will be broken. In the second case, the RO bond will be broken. In which the RO bond is broken, it is acting as an electrophile. Where the OH bond is broken, it is acting as a nucleophile. This thing is clear with everybody? This thing is clear with everybody? ठीक है? चलो, next is look at the substitution reaction. In substitution, look at this ROH species, which we have learned a lot about in haloalkanes chapter also. ROH, what has happened? This OH leaves and is replaced by the halide group over here. So which bond is breaking in substitution? In substitution, the RO bond is breaking. Remember this thing. In substitution reaction, the RO bond is breaking. Can everybody hear me? Can everybody hear me? Sorry. Okay. So substitution again, various kind of substitutions we read about in the last chapter. SN1 reaction, SN2 reactions. Okay. You must remember those kind, right? For example, what was the, I'm again going to revise for you guys. SN1 reactions were those which were the two-step reaction, which means there was a formation of carbocation in them. In SN2, it was a one-step reaction, which means there was no carbocation formed, and hence there was an inversion of configuration taking place. There was just a transition state forming. The attack was happening from the back side in the SN2 reaction, isn't it? Okay, so we took an alcohol, we tried to react it with the HX acid, and we are forming the RX group. Okay, now look at the mechanism. The mechanism is primary alcohols react by SN2 mechanism, right? While secondary and tertiary alcohols react by SN1 mechanism. We've already discussed this, because secondary and tertiary carbocations are more stable, hence they react by SN1 mechanism, and primary alcohols react by SN2 mechanism, because primary alcohols are least hindered and SN2 reaction attacks from the back. What is the reactivity followed for both the cases, bacha? For both SN1 and SN2, the reactivity of halides follows this order. HI is more than HBr is more than HCl. This is the reactivity order followed for both SN1 and SN2 reactions. Okay? The next is, now look at some of the mechanism just for revision. For example, reaction with halogen acids, we are reading about the SN1 mechanism. In SN1, what am I talking about? RX acid. RX should be HX. Just correct it, it should be HX. Okay? HX means X is the halogen. And we know halogens are more electronegative in nature. Hence, what will happen? This will take electrons towards itself and it will get converted into a nucleophile just like this. In SN1, it is a two-step reaction, which means there is a formation of carbocation. So, what is the first step in SN1? The H plus is attacked by the alcohol, and what happens? First of all, the carbocation is formed, which is a slow step, which means the leaving group leaves first, and then the carbocation is formed. More stable the carbocation, more will be the reactivity. Okay, and to this carbocation, then the halide ion attack, and the attack can be from both the sides, from the front, from the back, from anywhere. From both the sides, the attack can be there. Okay, because this is a very, very fast step. Hence, the reactivity order for SN1 mechanism is tertiary alcohols are more reactive than secondary alcohols, then your primary alcohols, then your methanols. Why? Because here carbocation formed and the carbocation stability order follows this order. Okay? This is the SN1 mechanism. Now answer this question for me. The order of reactivity for the following alcohol towards concentrated HCl is. Answer this question for me. You have been given an alcohol and you are trying to react alcohol with a HCl, which is the same reaction with the halohalide that we just read, halo acid. What will be the reactivity order followed? Again, tell me the answer to this question. So again, it will depend on the formation of carbocation, isn't it? So wherever the carbocation is more stable, that would be the most reactive ethanol, right? Reactive alcohol. Answer this question for me. Answer this question for me. I'm looking at the chat box once again. Oh, I keep falling down over here. First answer I've received by Supriya is D. Sanjay has answered C. Suhaib C. Jeevan C. Sanjay C. Only Supriya has answered D. Okay, bacha, let us look at the order once again. After this OH leaves, what will happen? The carbocation will be formed over here. So this is a benzylic carbocation. After this OH leaves, the carbocation will be formed over here, which is a what kind of carbocation? Secondary carbocation. Here, if the OH leaves, again a secondary carbocation is formed over here. If the OH leaves, again a secondary carbocation is formed over here. So we know benzylic carbocations are most stable. Hence we know fourth will be the most stable. Now between C and D we have to choose. Now which will be more stable in all of these cases? This is also secondary. This is also secondary carbocation. This is also secondary carbocation form. Okay. Now bacha, what is the criteria to choose? Now can you see that here fluorine groups are added in 1 and 2. Fluorine is shows the minus I effect. Everybody remembers that? Because fluorine shows minus I effect. Why? Because fluorine is more electronegative, hence it will pull the electron towards itself. It is showing minus inductive effect. And we know that inductive effect depends upon the distance. As the distance increases, inductive effect actually decreases. Remember that thing. Okay, so can you see here to this carbocation, the fluorine is attached just right next to it. But to this carbocation is formed over here. The fluorine is attached to 2 carbons after that. Hence, the inductive effect is decreasing over here. Most inductive effect minus I. So, we need to stabilize the carbocation. It is pulling electron towards itself. Hence, is it stabilizing the carbocation or destabilizing the carbocation? Hanji. Okay. So, the next stable will be the third option. Then it will be it is pulling the electron towards itself. It is pulling the electron towards itself. Hence, it is destabilizing the carbocation. Correct. So, fourth will be more stable. Then it will be your third option. And then between first and second, we have to choose, right? So, because in the second, the fluorine is more far away. So, second will come and then first will come. So, the answer is actually C. So, whoever answered C, your answers are actually correct. ठीक है? चलो. Yes, minus I is distance dependent and more stable, less reactive. Very, very good. Vermi Shetty, you are correct. You're correct. Chalo, next is we're talking about reaction with PCl3. This HX, mostly what happens, SN1 reactions are shown depending upon the stability of the alcohol form. But if bacha, what is given to you? PCl3 is used as a reactant. So you are reacting your ROH with PCl3. What are the products formed? The product formed is a RCl group and H3PO3 molecule. Here the reaction actually takes place through SN2 mechanism. With PCl3, the mechanism is SN2, which means it is a one-step reaction. What happens as soon as the leaving group leaves, then the attacking attacks simultaneously. So a transition state is formed. So the attack is happening from the back side. Okay? So here the reactivity order followed is that your methanols will be more reactive than primary alcohols, then your secondary alcohols, and then your tertiary alcohols. Why is that the case? Why is that the case? Because this is the case followed because the attack is happening from the back side. So as the steric hindrance increases, in tertiary, there are 3 methyl groups attached to the carbon and there is so much steric hindrance. And as the attack has to happen from the back side, there should be least steric hindrance possible. Hence, this is the reactivity order followed for the alcohols. Correct? Correct. So, the mechanism followed is actually, bacha, this mechanism is not important because it is not given in NCRT. But still, if you're curious about what are the mechanisms, how the PCl3 attacks from the backside, then this is the mechanism. Okay? Chalo, next is reaction with PCl5. With PCl3 also, it is SN2. With PCl5 again, it is a SN2 mechanism. Okay? Chalo, next. Next is again what happens with SOCl2. Again, what you're taking an alcohol. You're reacting it with SOCl2, and what you're getting, this OH goes away and this is replaced by the Cl group. Hence, this is called substitution. What kind? Nucleophilic substitution, right? Because the nucleophile is attacking. Nucleophile is Cl minus, correct? And this kind of product is formed, and we know this is the best method of preparation for your alkyl halide. Why? Because all of the products, which is SO2 and HCl, are gases, so they leave the beaker in which it is formed. It evaporates and we get a pure alkyl halide product. So SOCl2 is the best mechanism to prepare alkyl halide from alcohol. Okay? Next is, bacha, solve this question for me. So you have one kind of secondary alcohol given to you, and you are reacting it with SOCl2 and pyridine. So what will be the product form? Who can answer this question for me? Who can answer this question for me? Answer this question. I told you that it followed the SN2 mechanism. So what will be the product? It follows the SN2 mechanism. Sanjay has answered B. Suhaib has answered C. Okay. Correct answer is B, bacha, because if the OH leaves from this side, the Cl will attack from the back side, as inversion of configuration takes place. So if the configuration was like this first time, and SN2 inversion of configuration occurs, so Cl comes this side, CH3H7 goes that side, and so inversion of configuration takes place, hence B is the correct option. Very good, Sanjay. Very good, Jeevan. Very good, Vemi Shetty, Jana. Very, very good. Suhaib, ma'am, B in case of pyridine SN2. Yes, in case of SN2. Correct, correct, correct. Chalo. Next is acidic character of alcohols we're going to talk about. Now, we talked about the substitution reaction. In substitution, what was happening? We were breaking the ROH bond, isn't it? In substitution reactions, we broke this bond because we were substituting the entire OH with another halide molecule, right? But now we are talking about the acid character of the alcohols. Acid character means what? How will they show acid character? So this is the alcohol. So whichever gives away the H plus ion, whenever something gives away the H plus ion, it acts as an acid, correct? So it, after the H plus is lost, the RO minus remains, which is a very good kind of nucleophile. It is remains. So here, whenever we're talking about reactions as an acid, we are breaking the OH bond, correct? We're breaking this bond, OH bond, and we're talking about the acidity of alcohols. So whenever the acidity of alcohols is talked, acidity means what? Which has the ability to give away H plus easily. And what it will depend upon? It will depend upon the kind of anion that is formed. Remember that thing. For example, the kind of anion, what do I mean by that? After the H plus leaves, the anion is formed. The H plus leaves, the anion is formed. The H plus leaves and the anion is formed. Correct? Correct. Now we have to look at the stability of this anion. So how can we make the anion stable? So it already has a negative charge. If I already have a negative charge on me, I want to reduce that negative charge in order to become stable. But to this negative, what are you attaching? What you are attaching, bacha? You are attaching more electron donating groups. Tertiary is more what? CH3 is a plus I group, increasing electron density. Hence, this is the most unstable acid form. If this is most unstable, and this is the least acidic compound. So because in the this shows less plus I effect, in your methanol primary alcohols show less plus I effect, and these are the most acidic compounds. We have to look at the stability of the anion form. Whenever we are talking about the acidity order, we have to look at the stability of the anion form, and anything which is decreasing the negative charge on it will increase the acidity, and if it is increasing if I'm negative, you are adding more things which is making me more negative. How will I be stable? I will not. Hence, this is the least acidic and this is the most acidic alcohol. Understood this part? Chalo. Next question. Next is tosylation. So first acidity order we discussed. Now what are the reactions using this acidity, using the reactions as an acid of alcohol? So what happens? Tosyl chloride. Understand the structure of tosyl chloride. Very, very important structure, because in exams what happens? They will not give you the reagent like this. They will just give you the tosyl chloride was used. So tosyl chloride has a structure like this. And when I react tosyl chloride with any alcohol in the presence of pyridine, what actually happens, bacha? The H plus goes away. With tosyl chloride, H plus goes away. And this RO minus and H plus and Cl over from here goes away. So there is a subtraction of HCl molecule, and the rest of molecule then attaches and forms a product just like this. So this is again a kind of reaction as an acid, which means the breakage of OH bond is there. Okay? This is another example. Understood? Next is oxidation of alcohol. What am I doing? I'm oxidizing the alcohol. This is the structure of alcohol, right? This is the carbon with hydrogen, oxygen with hydrogen, right? Structure of alcohol. And what is happening in structure of alcohol? There is breaking of two bonds, two H bonds. One breaking is the OH bond is breaking. The other breaking is the carbon and hydrogen bond is breaking. Hence, what is happening? After these two bonds break, what is happening? A carbonyl group is formed. So, whenever you're oxidizing an alcohol, the first product that is formed is a carbonyl, whether it is a aldehyde or it can be a ketone product. Correct? Correct? And oxidation depends upon the oxidizing agent, and there's a cleavage of OH and CH bonds is taking place. Okay, bacha? Next we're talking about what kind of oxidizing agents we can use to convert your alcohols to either your carbonyls, which is your aldehyde or ketone. So number first, very, very strong oxidizing agent is KMNO4. Okay? With KMNO4, bacha, what happens? You took a alcohol, for example, you took a primary alcohol. What is it? It is a primary alcohol. So primary alcohol first gets converted into a aldehyde, and then it gets converted directly into acid. So remember, this is the order of oxidation followed. Also remember this thing. Order of oxidation means what? If I'm an alcohol, my first step of oxidation will be formation of an carbonyl, whether aldehyde or ketone. So first aldehyde is formed, and then from aldehyde directly acid is formed. Why? Because a very strong oxidizing agent is used, hence it cannot stop at just aldehydic or ketonic group. It will convert into acidic group because it is a very, very strong oxidizing agent. It oxidizes even the aldehyde or the ketone form. Similarly, primary alcohol first gets converted into aldehyde and then gets converted into acids. But if secondary alcohols are taken, like in this case, if secondary alcohols are taken and you're using the same strong oxidizing agent like KMNO4, then it converts into acetone group. Ketone groups are made. Ketone groups are made with secondary alcohols, with primary alcohols, aldehydes, then directly into acids. And tertiary alcohols are not oxidized by KMNO4. Remember this thing. Tertiary alcohols cannot be oxidized by KMNO4. Okay? Next is Jones reagent. If you are using Jones reagent to convert your alcohol into oxidizer alcohol, what will happen, bacha? You use Jones reagent is very popular. CrO3 with H2SO4 in presence of acetone. Okay? What is the product? Again, with primary alcohol, you get a acid. What are you getting? You're directly getting a acid as product. And with secondary alcohol, you're actually getting a ketone as a product, which is same as your KMNO4, which means it is also a very, very strong oxidizing agent. Okay? Understood this point? Next is PCC and PDC. That was strong oxidizing agent, KMNO4 and your Jones reagent. PCC and PDC are your mild oxidizing agent. Okay? Which means they are not able to convert the aldehyde into acid. Okay? So whenever you take a primary alcohol and try to react it with either PDC or PCC in presence of any non-polar polar solvent, then bacha, what will happen? The secondary alcohol gets converted into ketones and the primary alcohols get converted into aldehydes. So here what is happening, because it is a mild oxidizing agent, the aldehydes are not converting into acid. The reaction stops at aldehyde. Aldehydes do not get converted into acid. Okay? Beta, what notes were not given? I will give to you after this session for sure. Okay? I have the notes with me. I asked them to send. Otherwise, I will send it after the session is over. Okay? Chalo. Chalo. Next. Next is in presence of copper and heat. What is happening? What is happening with copper and heat? Again, bacha, this is a very strong oxidizing agent which we were talking about, copper and heat. So I again took an alcohol and I tried to react it with copper and I formed an aldehyde out of it. Okay? After I formed an aldehyde, what is happening? Okay? With primary alcohol, aldehyde is formed. With secondary alcohol, ketone is formed. But copper is also able to oxidize the tertiary alcohol and actually alkene is formed. And nothing else, alkene is formed with tertiary alcohol. So under that, understand this thing with copper and heat. With primary alcohol, the reaction stops at aldehyde. With secondary alcohol, ketone is formed. With tertiary alcohol, your alkene is formed. Okay? Shall I move on to the next thing? Next oxidizing agent is MnO2. With MnO2, bacha, what happens? The MnO2 is able to oxidize only those alcohols which are either allylic or benzylic. Remember this thing. MnO2 can only and only oxidize either allylic or benzylic alcohols. Allylic means here, for example, to the sp2 carbon, this is the sp2 hybridized, the double bonded carbon, and the carbon right next to it has the OH groups. Then this is called the allylic alcohol, right? So allylic alcohols are oxidized and the aldehyde is formed. Similarly, look at this. This is a C6H5 molecule and this is a CHOH. So this is a benzylic alcoholic species, and with MnO2, bacha, what is happening? You are actually forming a ketone group just like this. Is this thing clear to everybody? Is this thing clear? Beta, I will provide you the notes for sure after this session is over, both this session as well as the last session notes. Okay? If you have not received. Yes, but Jeevan, only allylic and benzylic are actually oxidized by the MnO2 reagent. Okay? Now, answer this question for me. Who can give me the IUPAC name or what will be the oxidized product of this reaction? So you have a molecule and you're trying to oxidize it with MnO2. So what will be the answer to this? Answer this question for me. Answer this question for me. Who can answer this? No, bacha. No, bacha. It will not remain same. Can you see that the double bond is over here? Double bond is over here means what? This carbon is sp2 hybridized, right? So therefore, this carbon becomes what? This is the sp3 hybridized carbon, and this becomes your allylic carbon, isn't it? Allylic position. Hence, this allylic positions OH will be oxidized into aldehyde. That's what I told you. Hence, the answer will be this. OH will be here. This is double bond, and here it will be a CHO group. So, this is the final answer. Okay? Because only this one will be oxidized. This OH will not be oxidized by MnO2 because this is not the allylic OH group. Only the allylic OH groups get oxidized into the aldehydic group. Allylic or benzylic by MnO2 reagent. ठीक है, understood? Now answer this question for me on your screen. Very, very important question. Now you will realize how to do basic kind of organic chemistry, which is very, very important. I'm going to teach you so many basic things out of it, which you have to apply in your JEE exam. I'm again and again telling you these things are very important. Now look at this molecule. Look at this molecule. First reagent that you are giving is PCC. PCC is a mild oxidizing reagent. Remember this thing. So what it will do? Then you are giving it a diol in presence of acid. Then you are giving it a RMGX in the presence of H2O plus molecule. Then you are reducing it with NaBH4ETOH. What will be the reaction? I'm giving you actually 1 minute to solve this question. Okay? You guys have 1 minute to solve this question. Try to attempt. Try to tell me out of these options what seems to be the probable answer for you guys. Otherwise, I'm going to tell you the answer, right? First of all, try. Draw the molecule. It's not hard. First step you must know it. PCC, mild oxidizing. It will oxidize both the primary and the secondary kind of alcohols. Okay, it is an oxidizing agent. Then what will happen with diols? What will happen with RMGX, Grignard Reagent? What will happen with the NaBH4, which is a reducing agent, right? Try to attempt this question. Try. Yes. Not getting B, bacha. Try. Chalo, I'll tell you. If you're not getting B, till B I'll tell you, then you tell me. Okay, till B I will tell you. So first is PCC. With PCC, what will happen? I'm trying to make the A product. Okay, with PCC, this is the molecule given to you, right? So here this OH will convert into CHO group. So this OH will convert into CHO group. Again, this OH should also convert into ketone group. This is a secondary alcohol, so this will get converted into a ketone. And this was a primary alcohol, so this gets converted into aldehyde. This thing is clear to everybody? To get this aldehyde, I can also draw like this. This aldehyde, I can also draw like C double bond O and H. Right? Now, next is bacha diol group is given to you. Diol group looks like this. This is OH, right? And this is the OH. So, this is your A molecule form. Okay, bacha, now what happens whenever some kind of diol is given to you? Try to react the aldehyde with the diol. Okay, the aldehydes mostly, the ketones not react with diols that much. Aldehydes are much more reactive toward diol. Then what will happen, bacha? What will happen? The H2O molecules actually goes away from here. Okay, the H2O molecules go away, and the product formed is actually, I'm again forming this molecule, which will be this. Here the ketone was there. Here the CH was there, right? CH. And the double bond was here. So double bond. So to this double bond, O will be here, O will be here, and this will be formed over here. But what is this called? This is called the formation of acetylation, or the hemiacetal group is formed over here. Okay, this thing is clear to guys. This still here, is it clear to everybody? So this is a different kind of reactant. So what did you do? What did you do? You just remove the H2O molecule and formed a ring just like this. This is called a hemiacetal ring or a acetal ring. Now, next what should be? Till here I told you this is the B product form. Now try to form C product, and from the C try to form D product. Okay? Till here it's clear to you guys? Now tell me what should be the answer. Now try to attempt. I'm again giving you just 30 seconds more to attempt. After that, what can you do? Okay, Parisjan is asking in class 10th, I want to do some portion of class 11. So, bacha, if you are in class 10th, then then there is a course provided by the Vedantu guys. Okay, you can check in the description box below. It must be by the name VLC Center. Okay, Vedantu Learning Center. There's a link in the description box. You can check out those links. In those links, there are various courses mentioned, which you can join if you're still in 10th standard. right? If you were in 11th or if you have completed the 10th, then I would have told you to watch the videos on this channel. But right now, the videos will be too advanced for you. So we have a bridge course for you guys who are the 10th moving to 11th. We do have a bridge course for you. Right now, we have not started on this channel. We're soon going to start. And if you want to know the schedule of that bridge course from 10th to 11th, then join the Telegram channel. We keep posting all these information there. But if you are very eager to join something right now, then you can go in the description box. There are various links mentioned. Just click on that link and try to log in onto the Vedantu page with your phone number, and you will receive a OTP. And after logging onto that link, you will get all the information regarding what all syllabus we have, what all the courses that you can do, and what is the best thing that can be done. You can even get a career counselor just for you, or you can schedule an appointment with a career counselor who can guide you through these steps. Okay? Now try to attempt this question with me. You've started 10th class, and bacha, my advice will be we have a bridge course. It is called the 10th foundation course. The details are in the description box below again. Okay, let me tell you, I've already, if you go to the beginning of the session, I have discussed the details. Okay, I've discussed the details. Beta, it is for free only. Nobody will charge you any money for that. You just have to call. It is for your guidance. There is a toll-free number. Even if you call in that number, there's no charges will be there. It's a toll-free number just to help students, because this is a free platform to help students, right? But if you want to get enrolled into the paid courses, which are the offline centers, then you can also inquire about that if it's in your city. Otherwise, most of the digital content is free on this app. But digital content is but lesser than the offline content. Why? Because offline there are classes, constantly classes, 3-hour long classes every day. Obviously, the content will be more, the lectures will be more, the test series will be more, right? Chalo. And if you've just started class 10, my advice would be enjoy class 10. Take enjoy class 10. But yes, some things, because keep more 70% of your time for enjoyment, because you are not going to get even 1% of your time to enjoy when you come in class 11th and 12th. It is you can ask these students here, they do not get even the time to even take their head out of the books or even the videos that they're watching, because the scores is so much. You'll get zero free time once you enter class 11th, and once you finish your class 10th, my only advice is do not miss, or do not skip even one day from learning, because if you did that, you are going to lag behind so much, right? But if you're so eager to learn class 11th, which you should be, then please check out whatever links are in, because they can guide you better than me right now. Okay? That's why I'm telling you that. Chalo, let us, nobody has given me the answer to this. So, bacha, what should be the next? Next is the addition of MgBr molecule, MEMgBr, which is RMgX molecule, right? So, what does it mean? The Me here will have a delta negative charge on it, and the Mg here will have a delta positive charge on it, isn't it? Because Mg is a metal, which is an electropositive metal. Me is a electronegative metal, right? So, what can happen? Can you see this ketone group over here? This ketone group, this carbon has delta negative, the oxygen has a delta, carbon has delta positive, oxygen has a delta negative, because oxygen is more electronegative. Then what should be the next step? What should be the next step? The Me, which has a delta negative charge, will actually attack this positive thing over here. Okay? Then what should be the next step? The next step should be the formation of, one second, sorry for this wrong structure. Yes. So the formation of this, here the OMgBr will attack, right? And here, bacha, the Me, that is CH3 molecule, will attack, and here will be O, and here will be, sorry, here again I'm making wrong. I don't know why I'm doing that. Probably because the teacher is so hungry today, I didn't have my lunch. So here, okay, here is a CH, and here it is a O, yeah, this kind of group is formed. Okay, this thing is here. This is your C molecule. Can everybody see? This is the C molecule that is formed. Last step is your, this thing is clear to everybody. Last step is your NaPH4 ETOH step. Now answer this question for me. You are doing reduction now. You are doing, so after this goes away, this is not your C molecule, sorry. C molecule is again, this OMGBr goes away from here because the solvent is given to you. Look at the solvent. Yes, the solvent is given to you. So the last molecule, C molecule will be here. The CH3 will come and here OH will come, isn't it? Here OH will come and here CHOO and here this kind of molecule. This is the C molecule. Okay? And after that you are reducing. What can you reduce? Can you see? NaBH4 is a very good reducing agent. It reduces what, bacha? It reduces this part. Will it reduce this part? Yes. This OO part, it can reduce. It can reduce into alcohol. है ना? This can reduce into alcohol. Hence, a final D product. Now, tell me the product from here. Now, tell me the product from here. What is the product that you can see is now here. This will break away. This will break away again from here. So, here only CH2OH will be formed over here. CH2OH will be formed over here. Okay? CH3OH. CH3OH will be here. CH3OH. So, this is correct. And CH2OH. This is B option is the correct option. B option is the correct option. Okay? Okay? Here what will happen? This will get converted into alcohol once again. This group will get converted into primary alcohol. Okay? Chalo, next. Next in your alcoholic reactions, very important is the MPV reduction and Oppenauer oxidation. So what happens in this kind of oxidation with alcohol, bacha? We actually take, for example, why are you asking my percentage? What is this obsession with teachers' percentage, bacha? I don't get it. But my percentage was 95 if you want to ask. But you should not ask that. Okay? You didn't get the last part. Tanishka is asking, you didn't get the last part. So, bacha, the NaBH4 is what? The NaBH4, I'm again going to tell you what is the last part. The NaBH4 is a reducing agent. And what it is? It is a reducing agent. So, can you see, can it reduce alcohol to anything? Can NaBH4 reduce alcohol? No, it cannot reduce alcohol. So, what else is there to reduce? The only other thing is the acetal part to reduce. So, this acetal part, it will reduce into alcohol. So, what will happen? This is again just like how you were reducing the esters and your esters and your acids. So, those are reduced by lithium aluminum hydride. But this is a hemiacetal formed over here. Hemiacetals are reduced by NaEH4, and what actually happens, bacha? What actually happens? One of the bond will break off. You break off one of the bond over here, and the final product that will be formed will be somewhat like this. Here is the OH product. Here is the CH3 product, right? And here is the CH2OH product formed. So this is the final thing that you will get, which is a primary alcohol here. This is the final reaction that you will get with NaBH4, because this whole thing will break off. And a primary alcohol will be left as a product. Okay? Because you started with the aldehyde. The aldehyde converts into primary alcohol. Correct? You can also follow that approach. Okay? Understood that part? A primary alcohol is formed. Understood, Tanishka? Chalo. Next. Next is, this is a very important, again, name reaction, which is the MPV reduction. MPV is Mirvin-Pondorf-Verley reduction. What happens? You take alcohol. For example, you take a ketone. You took a ketone or any carbonyl compound and you react it with alcohol axis. What kind of alcohol? Isopropyl alcohol. In the presence of aluminium isopropoxide, then what will happen, bacha? What will happen? Your ketone gets converted into alcohol, which is secondary alcohol, and your alcohol gets converted into ketone. Simple. Now, the right opposite of this reaction, this is a kind of reduction. Why? because here your carbonyl compound is getting reduced to alcoholic compound. This is a reduction. Now the reverse of this reaction is when I took an secondary alcohol and I tried to react it with excess of acetone. So what will happen? The alcohol gets oxidized to ketone, right? The secondary alcohol gets oxidized to ketone while the acetone that I took got reduced into secondary alcohol. So this is the exact opposite of each other reactions. In MPV, you just reverse the reactants. Here, the carbonyl group is getting reduced. Here, the carbonyl group is getting oxidized. Okay, and this is called Oppenauer Oxidation reaction. Understood this point? Understood this point? ठीक है? ठीक है? Very important name reactions once again that you should know. ठीक है बच्चा? Should we keep the lecture till here? Should we just keep the lecture till here because I've been speaking constantly from like more than 2.5 hours now. Are you guys not in NCRT? No, but not in NCRT, but still these are important kinds of reactions. For example, another important category of reaction is the Pinacol-Pinacol rearrangement reaction. In this, bacha, what happens? You take a diol, any kind of diols you take, and then on those diols, what is happening, bacha? Here, one of the methyl group, and in the presence of any acid you are heating it. Okay? In the presence of diols, what is happening? There is a CH3 group on one of the atom. Then what happens? This CH3 group actually migrates in presence of acid. So what actually happens? This CH3 group comes here and this OH group goes over there. So what is happening? For example, this was the compound CHC, CH here, and this CH3, this CH3 that was above there migrates to here, and the OH groups migrates to here. OH comes over here and the CH3 group is formed. Now, bacha, the geminal diols that you can see here, when the two hydroxides are on the same carbon, this is very, very unstable. Hence, what happens? One H2O molecule actually leaves. After the H2O molecule leaves, what happens? A carbonyl group is formed just like this. So in Pinacol rearrangement, what happens? When you have a vicinal diol and any alkyl group is present on one of the carbons, okay? And there is a possibility of rearrangement so that from vicinal diol there is a possibility of formation of a geminal diol after the methyl shift or after the alkyl shift, okay? And then after that shift has happened, due to the instability of the geminal diols, it gets converted into a ketone or a carbonyl compound. This simple rearrangement is called Pinacol-Pinacol rearrangement. Okay? Everybody understood this thing? But bacha, you have to remember because these are important reactions based on the examination. So I think we have done very much reactions from this. All the NCRT reactions, especially from the alcohols chapter, is completed. I told you about the physical properties of alcohols, right? And we also discussed various kind of preparation for alcohols, and then the reactions of alcohol. What did I tell you? The alcohols show two different kinds of reaction. One where the OH bond is broken. In there, they act as acids, right? One where the RO bond is broken, where they act as actually RO bond is broken, act as electrophiles, right? They show nucleophilic substitution reactions, right? And they also show oxidation reactions. So many reagents we discussed. What are their properties? All of these things we discussed, right? So we are going to stop this over here and ठीक है चलो. If you have any questions, bacha, we can use any other product than acetone. Yes, we can definitely use. We can definitely use with the Oppenauer reduction. Only remember one thing, if one thing gets oxidized, the other thing gets reduced. It happens in the presence of a very strong acid. ठीक है चलो. Thank you for attending the class. I'm going to end this lecture over here. Thank you so much. If you have any questions related to the things that we did today, and you have any more feedback, ma'am, I am not understanding that. If you have any doubts, then please ask me in the comment section after this live is over. Whatever doubts you have, mostly doubts, I will clear to you. And also, you can connect with me on the Telegram. On the Telegram, I send you notes on the channel that is linked down below. Join them, and I will send you notes for yesterday class. If it is not uploaded, I will upload that even for the today's class. Thank you for attending, and we will meet again in the next lecture. Thank you. Goodbye. Have a nice day, everybody.